Hi everyone, we're going to be looking at our new unit which is called Variation and Rates of Change, and it actually has a lot to do with what we studied last term with linear relationships. We're going to be looking at if there's a relationship between two variables. So for example, speed of a car versus how long it takes to get somewhere, height versus your arm span, that kind of thing. If there's a relationship between those variables, what kind of relationship it is, and if we can use one variable to predict what the value of the other variable would be. In order to do that, you need to be able to plot with two variables, and we were doing this last term with our x and our y variables here. So we can easily plot this quite straightforward. So if our x is -2 in this situation, our y is -5. So x is -2, y is -5, x is -1, y is -3, x is 0, y is -1. You can see that we're getting a linear relationship here. X is 1, y is 1. Now obviously if I don't plot these too accurately, we may not end up with a very accurate straight line, but bear with me and pretend that we are being very accurate with that. And we then could draw a line through those. So if I go ahead and insert that line straight through them, depending on how accurate we've been with our plotting points, we might end up with a accurate line. That's what we were doing last term. And obviously we would prefer it to be more accurate, but this is where we're at today. So we plot our points, we get our line. What happens if we have variables that aren't just x and y? So for example, if I have oranges are sold for $3.50 per kilo and we have a bunch of weights of oranges and their corresponding price, do we plot a graph that looks like this with our price on the y-axis and our weight on the x-axis? Or do we plot it the other way around where the weight is on the y-axis and the price is on the x-axis? Those are our two options. And the issue is that they produce two different lines. So let's look at this first one here where we have our weight on our x-axis down the bottom. So I'm going to use blue for that one. So if we were to plot our weight being 1 kilo and then 3.5, so right there. Weight of 2 kilos, we've got right on 7 there. 3 kilos, 10.5, which is about there. 4 kilos, we can't go because it's already up here. But notice that we've got a reasonably straight line here, and we can draw our line in. Which is fairly accurate. And we have a very steep line here. So as the weight of our oranges increase, our price increases. If we plot it the other way around, and we have our price is $3.50 and we get 1 kilo of oranges, right there. Our price is $7 and we get 2 kilos. Notice already, we can already see that I'm going to end up with a much less steep gradient. 4 kilos, we end up with 14. I'm going to go straight to them. Oh, and I skipped one, so 3 kilos, 10.5. Right around there. All right, and if we draw our line, as you can see, it's much less steep in that one there. So which one is the correct line? Because they can't both be correct because we have two different lines here. And the correct one is actually this first one here because we have our weight on the bottom and our price on the side. So this one is actually incorrect. We can't graph it like that. And the reason is because our weight is independent of the price. And when we're graphing two variables that aren't just labeled as x and y, we need to make a decision as to which one is the independent variable that we're going to put on the x-axis and which one is the dependent variable that we put on the y-axis. So it should look like this. Our independent variable on the bottom on the x-axis and our dependent variable on the y-axis. And we have some definitions for that. So the dependent variable relies on the independent variable. So with our case of oranges, the price is affected by how much weight you buy in the oranges. And we can also think of these as cause and effect. So this is the cause, the weight of the oranges, and this is the effect. Not sure why that's coming out green. So it's affected by this one. And we're going to look at a couple of other ways that we can identify the independent and dependent variable. So let's say we had this one here. So the higher the temperature of the air in the oven, the faster a cake will bake. Which one should go down on our x-axis? And that has to be the independent variable. And in our case, it's the temperature of the oven, because we don't just time a cake baking and then decide what temperature that oven is. The temperature of the oven is the first one, and then we measure how long it takes to bake, and we put it in there. So this would be the temperature of the oven. And our y-axis would be how long. On our y-axis. Just there. So, and we would expect this to have a fairly linear relationship. So the higher the temperature, a linear relationship going negatively. So the higher the temperature, the less time it takes to bake the cake. The lower the temperature of the oven, the more time it takes to bake. So it looks something like this. Let's have a look at this one. When making pasta, you need 100 grams of flour per person as an approximate thing. Down the bottom, we would have our people, because per person would be our independent variable. And our flour is what we're measuring. So say we had 10 people, we'd need a kilo of flour. We had 5 people, we'd need 500 grams of flour. So we'd have a graph that looks something like this. Let's change it from green. Something like this. And we would have our people here and our flour, grams of flour on this side. Again, because our people are independent of the amount of flour that we use. We'd start with the amount of people and we'd go, okay, that's how much flour I need. The flour is the dependent variable, so it goes on the y-axis. Let's have a look at this one where we actually do plot it. So I've got this table of values here with our hours spent studying versus exam mark. And in our table of values, we've got a bunch of time that people spent studying and the percentage grade that they got in this completely made up exam. So let's say that this person spent 2 hours studying and they got a grade of 16%. So let's go ahead and plot that there, and I'm going to make this down the bottom, which we're going to make the bottom our independent variable again. And what's our independent variable in this case? The independent variable is the time, because time doesn't change for anyone. It's the amount of time spent studying, and that affects the grade that they got. So the grade goes on the side on the y-axis. So we've got grade will go here because that's our dependent variable, and down the bottom we're going to have hours spent studying. So our grade's on the side, and we should always put the unit there too. So grade percentage, hours spent studying, down the bottom. So our first person, I'm going to make this also, this is in terms of actual hours. So make this 1 hour. These can be 2, 3, you get the point. And then on the side for our percentage, I'm just going to make that 10%, 20%, 30%. You get the idea. All right, so we have our percentage and our hours spent. So this person spent 2 hours studying and they got a grade of 16%. So that's about here. This person spent 2.5 hours studying and they got right on 20%. So right here. this person spent 8 hours studying, so 1, 2, 3, 4, 5, 6, 7, 8, 8 hours studying, and they got a grade of 64%, so that would be 50, 60, around there. 64%. Around there. 6 hours studying, we're coming back. 4, 5, 6 hours studying, they got a grade of just under 50%. There. And you can see we're getting lots of little different dot points there. And then finally, our last person spent 11 hours studying and did the best. They got 11. They got 88%. So 4, 5, 7, 8, 9. Oh, I did draw 11. 11, and they got 60, 70, 80, 88%, around here. Around there. So notice that in this scenario of completely made up marks, we do have a linear relationship here. And when we keep studying, you'll learn that this is a proportional relationship. And we could go ahead and put a line through those points to show that they do relate. This is called a scatter plot because we've scattered all our dot points throughout. And we're going to be doing a few of these in the lessons to come. So we could just draw our line through there. Hopefully that makes it more clear for you. This will be our what's called a line of best fit because they don't quite all add up there. And hopefully that makes sense to you, and that's what we're going to be doing starting next lesson as well. Thanks.